Hello everyone, happy to see you here. Welcome back to my channel Hi Mathematics. Today we have a very interesting equation t square minus t cube equal to 12. We need to solve this question for t, so if you have your answer, your solution, you can write it in the comments below and then we will check our answer. So it will be really interesting. So first of all, let's subtract this 12. So let's write this 12 on the left side, okay, but with negative sign. Okay, we just write it on the left side. So we have t square minus t cube. And we have minus 12, okay, minus 12 and equal to 0. Right now, this 12 can be written, of course, in a lot of ways. So this 12 right here, this 12 right here, we can write it as 6 plus 6, for example. This is the obvious way, but I recommend you to express this 12 as 8 plus 4. Okay, let's do it. Let's choose this way. How can we express this 12? So let's start with that. First of all, what do we have on the left side? So we have t square minus t cube. And minus, as I said before, instead of this 12, we write this expression 8 plus 4. So 8 plus 4 and equal to 0. Okay, really great. Right now, let's open a parenthesis real quick. So we have t square minus t cube minus 8 and minus 4 equal to 0. And right now, a lot of students may be asking why we do this, why we express this as 8 plus 4. And here's my quick explanation, because 8 can be written as 2 cube. And 4 can be written as 2 square, and it's also really great to have these cubes and square, considering the fact that we have this expression in the beginning, square and cube, and then we can group it, okay? So let's start with that. As a result, we have t square minus t cube minus, instead of this 8, we write 2 cube, okay, 2 cube, and minus, instead of this 4, we write 2 square, okay, 2 square. Okay, I really hope you understand it. Right now, we're gonna group squares, so this square right here and this square right here, and we have t cube right here and 2 cube and 2 cube right here. So let's group it, okay? As a result, what do we have? First of all, I want to group squares, so we have t square minus 2 square, yeah, minus 2 square, and we have minus, in another parenthesis, we have t cube minus 2 cube, okay, t cube minus, or plus right here we have, yeah, t cube plus 2 cube, because we have parentheses, t cube plus 2 cube. Okay, really great. And right now, let's look closely from different angle, because what do we have right here in this parenthesis? We have a difference of squares, and we know this formula, okay? I just want to write this formula right here real quick. So what do we have? X squared minus y squared. So this is equal to x plus y, x minus y. Everyone knows about this formula, x plus y and x minus y. Really great. And the second formula, but what do we have right here? This is not a difference of squares. This is another case. This is a sum of 2 cubes. So let's remember this formula. So we have x cube plus y cube, x cube plus y cube. Let's remember this formula. Okay, so we have x plus y right here, the same beginning, but we have another parenthesis right here. So we have x squared minus xy and plus y squared. Really great. And right now, let's apply difference of squares right here, sum of 2 cubes right here. Let's do it right now. So I'm going to start from here on the left side. So as a result, what do we have? The first thing, what do we have? We have t plus 2, t minus 2, yeah, t plus 2, t minus 2. This is our first parenthesis, and in another parenthesis, what do we had from here? Minus t plus 2, the same thing. So we have t plus 2, and in other parentheses we have t squared minus 2t and plus 2 squared, so plus 4. And right now, let's see once more. Let's look at this question from a different angle. So what do we have right here? We have a product of like 2 parentheses right here at this place, 2 parentheses right here. We have subtraction, but the most important thing is to see the common expression, t plus 2, and we have t plus 2 right here at this place. So basically, we can factor this t plus 2. So let's do it right now. So we have t plus 2, and in another parenthesis, what do we have from here? Okay, so from here we have t minus 2, so let's write it, t minus 2 from this parenthesis, and in another parenthesis, what do we have? We have minus, and this one, we still have this expression, so minus t squared minus 2t, and plus 4. Really great. We factor it, everything is great, but we need to simplify this expression. Let's do it. Let's do it before solving this question. So we have t plus 2 in the beginning. And in another parenthesis, we have this one without parenthesis. We can actually get rid of this parenthesis because we have a positive sign. So we have t minus 2. Right here, we need to change all the signs to the opposite one. So we have minus t squared plus 2t and minus 4 equal to 0. Right now let's simplify it, but what I mean simplify, we need to like change an order a little bit because we prefer a classic order, because this is a quadratic equation, so we need to write this second t square on the first position, so we have t plus 2 without any changes, and right here minus t square on the first position, so minus t square on the first position. On the second position, t plus 2t, so we have plus 3t, and minus 2 minus 4, we have minus 6, yeah, we have minus 6 and equal to 0. But I recommend you to multiply both sides by minus 1, because then you will multiply it instantly, because you need to solve this quadratic equation. But I recommend you to multiply right now by minus 1, because we prefer a classic order of signs. Yeah, we don't like this negative. A lot of students don't like this negative sign in the beginning, so that's why we write this without any changes, t plus 2. But this one, we're gonna change all the signs of t square minus 3t and plus 6 is equal to 0. So really great. Right now we can easily say that we factor this question correctly, and right now let's continue our solution. So a product of two parentheses equal to 0 when the first parenthesis equal to 0, so t plus 2 equal to 0, or the second parenthesis equal to 0, so t square minus 3t and plus 6 equal to 0. So we have two equations, but the main thing right here, both equations are easy for us, because right here linear equation t plus 2 equal to 0, from here t first equal to minus 2, this is our first root, yeah. And right now the quadratic equation, I'm going to solve it with the basic method, because this is up to you. How do you prefer solving this type of questions? But maybe a lot of students watch my video, so I'm gonna choose a basic method. So a equal to 1, method of coefficients, b equal to minus 3, yeah, and c equal to 6. Okay, here's our coefficients, and right now let's solve this quadratic equation. First of all, we can easily find the discriminant. So discriminant equal to b squared minus 4ac. This is my way, because like every time I have a quadratic equation, I solve a discriminant real quick. Yeah, so then we have like minus 3 squared minus 4 times 1 times 6. As a result, what can we get from here? So minus 3 squared, we have 9 minus 24. So as a result, we have minus 15. So our discriminant is less than 0. So it means that in this branch right here, we will have like two complex roots. So right now let's solve it. So as a result, t first right here, so our complex root, we can write with this index 2 and 3 equal to. So we have minus b plus minus square root of discriminant and all over to a. So minus b minus, but b minus 3, so we have minus 3 plus minus square root of discriminant, square root of minus 15, yeah, and we divide all of this by 2a, by 2 times 1. As a result, this one we can split like square root of minus 1 times square root of 15 in terms of a basic square root property. But before this, minus minus we have plus, so we have 3 plus minus square root of minus 1 times 15, like that, and all over 2. And right now, as I said before, we can easily split it in terms of like square root property. So 3 plus minus square root of minus 1 times square root of 15, because we can't express 15, you know what I mean, when we have like a great case, like for example square root of 18, yeah, we can write it as 2 times 9 and square root of 9 equal to 3. So we can, in some way, we can simplify this. But in this case, square root of 15 is not a good value for us, so we leave it like that. Square root of minus 1 is our I, so we have 3 plus minus I square root of 15 and all over 2. And a lot of students prefer splitting this answer by two parts, by real part and imaginary part. We can easily do this, so we're going to divide our numerator by 2. So 3 we're going to divide by 2, plus minus this one, I square root of 15, we divide by 2. And right now at this moment you can see the real part and imaginary part. So we have two complex roots right here. Okay, so let's write this answer right here. So I'm going to write it as t second and third equal to 3/2 plus minus I square root of 15 over 2. So right here I want to underline it, that this is our answer to our question. Yeah, so right here this is our answer. So this one root is real number root, and of course these roots are complex roots. You can easily see it at this place. Right now, the final thing, we're going to check real quick our t first equal to -2, and let's do it right now. So as a result, we have t squared minus t cubed equal to 12. So here is our question from the beginning. Let's check real quick our -2. So we have -2 square minus -2 cube equal to 12. Okay, what can we get from here? -2 square equal to 4 minus the sign right here when we raise to the third power will be negative because we have an odd power, so it means -2 times -2 times -2. It means the sign will be negative. With this negative we have positive. 2 cubed equal to 8. So as a result, we can easily say that our answer is absolutely correct. Real number root is absolutely correct. And if you think about this question, yeah, we have right here our question. So with t squared, right now we can easily see real quick a solution. So t squared minus t cubed equal to 12. Right now, a few thoughts about this question. So real quick, 1 minute, I'm going to say a few thoughts about this question, because there's like a really important moment called like a fundamental theorem of algebra. It means that I'm going to say in simple word, because a lot of students don't understand this thing, but there are a lot of ways when you can solve this question with the wrong amount of roots. For example, you have an equation and you solve and you say, okay, I have 6 roots. But here's one really important moment. You can easily scan this information. So what does it mean? It means, for example, we have an equation, and right now we need to scan what is the highest power in an equation. So right here at this place, the highest power is 3. So it means that we have 3 roots in total. We don't know how many real number roots, how many complex roots, but we have 3 roots in total. And here is a proof. We solve this question with the 3 roots. For example, imagine you have like t squared, the highest power, and you solve this question with 3 roots, then it means that something went wrong, because there is no way you will have like 3 roots in a quadratic equation. Yeah, well, you know what I mean. When you have a quadratic equation, there is no way you have like 3 roots. And every time you have an equation, instantly you can find out what is the amount of roots, how many roots do you have in total. Okay, so for example, in this case, t cubed, it means 3 roots in total. How many real number roots, how many complex number roots, you don't know exactly. In our case, when we solve it, we can easily say, okay, real number root 1 real number root, and 2 complex roots. Okay, so I hope you understand it. T to the power 5, it means 5 roots in total, maybe 2 real, 3 complex, 3 real, 2 complex, or other different combinations. Okay, so I really hope you understand it. Once more, you can easily see a solution. You can easily pause the video real quick and write your assumption, write your answer in the comments below. Write your thoughts, write your how can you see solving this question. And of course, I'm really appreciate that you leave your response, and I'm really grateful for everything you do for my YouTube channel, for watching my videos. I really appreciate it. So wish you all the best in your life. Take care of yourself and have a great day. See you in the next videos.